Hi guys, so my name is Anthara and I'm gonna go ahead and share my screen right now. So today I'm going to talk about quadratic equations. Yeah, so today I'm going to talk about quadratic equations and, sorry. So basically, I wanted to talk about, first of all, what is a quadratic equation? So it's basically a polynomial equation of second order or degree of 2. So that's why the highest order would be, like if you had an unknown variable of x, it'd be x squared in that equation. And usually the standard form is given as ax squared plus bx plus c equals 0. So in this case, a, b, and c are known constants. And a cannot be 0 because if a is 0, then that value of ax squared just goes away and it becomes a linear function or linear equation. And in this case, the unknown variable is known to be x. So just to give an idea of what these quadratic equations look like, so they are shaped as a parabola, and usually the roots are where the curve crosses the x-axis. So on the right-hand side, we have an equation of y equals x squared minus 8x plus 12, and we have the associated curve with it. And here, the curve crosses the x-axis at 2 points, at 2, 0, and at 6, 0. So this curve has two real solutions, one at x equals 2 and at x equals 6. And the vertex is given at negative 4. But you can also have one real solution, which is where the vertex basically touches right at the x-axis. So it doesn't touch anywhere else, just one point on the x-axis. And then you can also have no real solutions where it doesn't pass at any point through the x-axis. I actually have a link here to a website that allows us to kind of play around with these coefficients and how these different coefficients may change how the graph looks. So if we look here, let's start out with a positive a value and just start out with something that's more familiar looking. Sorry. So here, this looks kind of similar to the previous graph, just different coefficients where we have two real solutions. And this is a parabola that's parabola that's opening upward. So here we have a graph that has two real solutions and it has a parabola that's opening upward. And the value of a is positive when a parabola opens upward. But say if we were to change it to a negative value for a, so a is the coefficient in front of x squared, it basically turns the parabola downward. So it's now a downward opening parabola. And there are cases where if you change it around, like you can shift the places where the vertex is. And as you can see, if I change C here, I can change to having only one part of the, basically the vertex being the only thing that's passing through the x-axis, where I have one real solution. So this is kind of just to give you an idea of how these quadratic equations look in terms of their graphs. So now going back to the PowerPoint. So basically going back to the PowerPoint, so here we looked at the graphing the quadratic equations. There are a few ways that we can try to find solutions to these quadratic equations. The first way is factoring the quadratic. The second way is called completing the square root, which I'll explain about later. And then the third way is the quadratic formula. So basically, looking at our factoring the quadratic equations, a helpful property to know is this zero product property, which is basically, so this is already in the factored form, where we have the quantity of 3x plus 2 times the quantity of x minus 3 equals 0. So the thing with this zero product property, say we call 3x plus 2 that quantity, say we call that A, and we call the quantity of x minus 3 B, and we simplify it into A times B equals 0. So basically with the zero product property, we have to have A or B, or both A and B, they have to equal 0 in order for this equation to be true, since it has to equal 0. So because A or B could be equal to 0, we can basically take the two different expressions of 3x plus 2 and x minus 3 and divide them up into two separate equations, where we have, on the left side, we have 3x plus 2 equals 0. So that's one equation we can get out of this. And then x minus 3 equals 0 on the right side. And then we can go ahead and isolate the variable of x by, for 3x plus 2 equals 0, we can go ahead and move the 2 to the right, and we get negative 2 on the right, and then divide by 3. So one solution we get is x equals negative 2/3. And on the right side, we can move over the 3 and get x equals 3 as the other solution of this equation. So basically, I have a few examples. The first one is easy and they'll get a little bit harder. So I'm just gonna go ahead and switch to my writing board on my laptop so that we can go ahead and write. I can go through these together with you. So basically, I'm going to turn off my video because I have to turn my camera around. So basically here, the first problem we had on that slide was, so this is factoring. I'm gonna use a different color just to be more. So here we have factoring. So this is our first way that we're gonna try to find solutions, is factoring these quadratic equations. So this first problem we had on that slide was 6x squared minus 2x equals 0. So kind of similar to the previous slide, we want to divide up this expression so that we kind of can, so we can take each of the expressions that we divided up into and make them equal to 0. So when looking at this, we see that 2x can actually come out of this expression, since 6x squared, 2x is a common factor in both 6x squared and negative 2x. So here you can actually bring out 2x, and then when you bring out 2x, when you do 6x squared divided by 2x, it becomes 3x. And then we have negative 2x divided by 2x, that becomes minus 1, and this is still equal to 0. So now, like in the previous slide I showed, we have this one expression, which let's say we call A, and this other expression we call B. And we know, like we had said, that A times B equals 0. So we're going to do a similar thing where we divide up this equation into two equations for 2x equals 0 and 3x minus 1 equals 0. And now we can go ahead and solve for x in both situations. So on the left side, it's pretty easy. You're just going to divide over the 2, and 0 divided by 2, that's 0. So we have one solution here. And then on this side, we're going to add the 1 to the other side. And then we're going to divide by 3. And then we get x equals 1/3. So this was a pretty easy example that we're looking at where we just had to factor out the greatest common factor. So basically, we'll move on to the next example, which is just slightly harder. So in this example, we have 3x squared plus 18x plus 27 equals 0. And here we have to factor this basically. So what I usually like to do is I usually like to write down for this coefficient of a, I like to write down the factors for 1 and 3. And then for here, the different factors for 27. So you can multiply 1 and 27, and then 3 and 9. So looking at these factors, I basically have to join the left side factors with the right side factors. And I don't think that the 1 and 27 will work out. So those I can cross out, but I can use different combinations of this on the left side and this on the right side to factor this out. So one thing I could do, if I want to get 18x in the middle, I can basically do 1 and 3, and then 3 and 9. So that basically means it's going to factor out into, so this 1 corresponds with the x, and this 3 on the right side corresponds with just a constant of 3, and you can multiply that by 3x plus 9 equals 0. Now, just to check that we're doing this factoring right, we can go ahead and FOIL this. So we can go ahead and FOIL, and we have 3x squared. So that's the first. And then we have the outside plus 9x, the inside 3 times 3x, that's plus 9x. And then we have the last numbers, 3 times 9, that's 27. And that simplifies into what we had before we started. So now we know that we did factor correctly. So in a similar way to the first example we did, we're going to separate these two into x plus 3 equals 0 and 3x plus 9 equals 0. And on the left side, we come out with x equals -3 when we isolate x. And on this side, we have to do a little bit more work. So we bring over the 9, and then we divide by 3. And it looks like we have the same solution for these. So basically, the solution is there's one solution, which is x equals -3. So now we will do a slightly harder example with this. So the next example we have is it's the quantity of 2x plus 3 squared minus 6x equals 9. So this is a little harder because you can't really start off with this. You can't really go straight into factoring it out because you have a variable of, you have -6x, but you also have this quantity of 2x plus 3 that's squared. So if we want to isolate x, we're actually going to have to expand this expression. So basically, we're going to have to, just to write it out, we're going to have to FOIL out that 2x plus 3 squared. So that's basically the same thing that we did, and just to check our work in the previous question. And I'm just going to bring over the 9 to this side, since we anyways want it equal to 0 in order to use that zero product property. So same thing, we're going to do the FOILing, where it's first, outside, and then inside, and then the last numbers. So we have 4x squared, and then we have plus 6x, and then plus another 6x, and then plus 9. And then we have this minus 6 here and minus 9, and that's all equal to 0. And now when we look at this expression, we can see that we have this positive 9 and negative 9, which actually cancel out with each other. And then we have one positive 6 and one negative 6, which also cancel out with each other. So then we're left with 4x squared plus 6x equals 0. Now, if we remember in the first example we did, we used the greatest common factor to help factor out a certain number and simplify from there. So in this case, I can see that x is a common factor in here, but also 2 is. So we can bring out 2x. So if we bring out 2x, 4x squared divided by 2x, that is 2x. And then 6x divided by 2x, that's plus 3. And that's still equal to 0. So just like in the past two examples, we have these two expressions that are equal to 0. So we can simplify them into two separate expressions or equations equal to 0. So we have 2x equals 0, and then we have 2x plus 3 equals 0. So on the left side, pretty easy, divide by 2, and it becomes x equals 0. And on the right side, we're going to bring over the 3. So it's going to be 2x equals negative 3. And then we are going to divide by 2 to get the x alone. So it's going to be x equals negative 3 halves. So here we have our two solutions. It's x equals 0 and x equals negative 3 halves. So this is basically what it is for the last example. And so this is basically some of the basics to factoring these quadratic equations, or with these examples. Now to just go back to the PowerPoint. So here we basically finished these examples, and now we can go ahead, and our next topic is going to be completing experiments. So this is a slightly more complicated topic, but it uses a similar idea to factoring. So basically, it's where you start out with the standard form, which is the ax squared plus bx. So it's the ax squared plus bx plus c, and equal to 0, and you try to get it to a form where it's a times x plus d, quantity squared, plus e equals 0. So basically, in order to get it into this form, we want to divide by the constant a. So we have a coefficient of 1 as a all the time. And then we're going to move that c divided by a over to the right side. And we're going to complete the square on the left side and balance at the same time on the right side. And in order to solve for x, we're going to have to take the square root on both sides and then isolate x. This sounds a little confusing and long-winded right now, but I think when we do the examples, it should make a little more sense as to what we're talking about here. So basically, let's start out with, I'm going to go ahead and switch to my notepad again so I can write out these examples with you guys. So basically, sorry, just one.
Hey, sorry about that. I was on the phone with somebody.
Oh, that's okay.
Are you all done?
No, I'm not done yet. I had some technical difficulties, I
Oh
think.
no. Oh, I'm so sorry. Okay, what's up?
No, it's okay. I think I accidentally hit the pen screen, like the pen button, and it, oh, I think it's because I forgot to switch out of tablet mode, so it's been a little confusing.
Got it. Okay.
Okay, I think I should be able to get back on track again.
You're back in. Okay, cool.
Yeah. Yeah, I should be good now.
Okay.
Yeah, so now we're gonna go ahead and switch the notebook so I can work through these examples with you guys. So here we have so this is going to be completing the square. So I have a couple of examples that would probably make more sense rather than what I talked about in the slides. It's always easier to understand through examples. So my first example, I start out with x squared plus 4x plus 1 equals 0. And basically, I'm trying to get a part of this equation to turn out into a square. So basically, I'll just show you. So here I'm going to bring over the 1 on the left side to the right side. So it's going to become x squared plus 4x equals -1. And so I'm basically going to be completing the square on the left side, but at the same time, I'm going to need to balance whatever I do to the left side on the right side as well. Otherwise, it won't be an equation anymore, since both the left side has to equal to the right side. So I'm actually, in order to complete the square, I'm going to actually put like a space where I need to write something on both sides. So on the left side, I'm trying to get a quantity that is squared. So in order to do that, let's call this this number 4, let's call that b, the letter b. So basically what I do is I take b over 2 and I square that to get the number here. So when I'm doing that, I'm going to take 4 divided by 2. I'm going to square that. And so that's going to be 2 squared. That equals 4. So I'm going to put 4 here, but whatever I do to the left side, I need to do to the right side as well. So when I go ahead and simplify the right side, it goes x squared plus 4x plus 4 equals 3. But on the left side, if I look, I can actually factor that expression of x squared plus 4x plus 4. And that factors into, I have the factors of 4 can be 1 and 4 or 2 and 2. So 1 and 4 is not going to work to get the middle 4x. So they're not going to work, but I can use the factors of 2 and 2. In order to do that, I can basically do x plus 2 times x plus 2 equals 3. And just to check, we can go ahead and just check if x plus 2 times x plus 2 works. So that's going to equal, if we want to FOIL it, so we're going to do first, outside, inside, and then last. So that's going to equal x squared plus 2x plus 2x plus 4, which equals x squared plus 4x plus 4, which is exactly what we had before. So this expression can be simplified into x plus 2 quantity squared equals 3. Now, this expression can actually be brought to, so the 3 can be brought to the left side in order to make this into vertex form. So this is actually called vertex form. I just didn't want to go extremely into quadratic equations and the graphing, but this vertex form is what is usually used to find the vertex of the parabola and basically graph these equations. Because, so basically if we were to talk about this equation, if you want to graph it, it would turn into the function of y equals x plus 2 squared minus 3. But I'm not going to go into that today. I just wanted to highlight that as a reason that we do completing the square. But going from the step I'm just circling right now, you can actually go ahead and solve for x. So in order to solve for x, you want to isolate x. So you need to get rid of that square. So in order to do that, you're going to square root both sides. And when you square root both sides, you're actually going to get a plus or minus radical 3 on the right side. Because when you square root, you get the positive and negative answer. And then now it's pretty easy where you just subtract the 2 and you get, I'm just going to put the 2 out, negative 2 out front, negative 2 plus or minus radical 3. So that's the solution. It comes out to be 2 solutions. So it's like negative 2 plus radical 3, and then x equals negative 2 minus radical 3. So those are those 2 solutions you get from completing that square. So then the next example is just slightly harder because it just has the coefficient of a is not 1. So you have to do a little adjustment. So this equation we're going to work with is 5x squared minus 4x minus 2 equals 0. So first thing we want to do, we want this coefficient in front of x squared to be 1. So we have to first divide by 5 throughout this equation. So when we divide by 5, it becomes, so we're going to divide by 5. That becomes x squared minus 4/5 x minus 2/5 equals 0. So basically, we have this as the equation we're going to work with. And just like we did in the last example, we're going to bring that constant over to the right side, and we're going to put some spaces where we need to fill in for completing our square on the left side, and then what we need to add to the right side to balance. 2/5, and then we add whatever number we add to the left side. So last time we called this, let's say this is called b. And again, we're going to do the same thing, b over 2 squared. So in this case, it's going to be -4/5. And over 2 is the same as multiplying by a half and square that. So we just simplify, that's a 2, this goes to 1, and it's -2/5 squared, which is 4/25. So we have 4/25 here, and then we have to add a 4/25 on the other side. Now, just like we did in the previous example, we have to basically find a quantity that can be squared to get that left side equation. So the quantity that you're going to get is going to be the b over 2. So it's going to be x plus b over 2. So here b over 2 is basically, like we said, -4/5 times 1/2. That's going to be -2/5. So you're going to have to do x minus 2/5, and it's going to be squared. And then you have, just to simplify the right side, 2/5 is the same as 10/25. And then you can add those together now that they have the same denominator, and you get 14/25. So just to check that the left side of x minus 2/5 is the same as what we started with, we're just going to FOIL again, just to check. It's always good to check, just to know if you're doing it right. So you're going to have x squared minus 2/5 x minus another 2/5 x, and then plus 4/25. And it comes out to be x squared minus 4/5 x plus 4/25. So that's exactly what we had on the left side, so it's all good. And now we're going to simplify this to solve for x. So we need to take the square root, and we have x minus 2/5 equals a square root of 14. So the square root of 25, we know that is 5. And we're always going to have a plus or minus when we take the square root in front. And then we can solve for x. So it's going to be 2/5 plus or minus the square root of 14 over 5. And that's basically the same as these two values of 2/5 plus square root of 14 over 5, and then 2/5 minus square root of 14 over 5. So those are the two values of x that we can get from this. So this is a little more complicated than just factoring, but it's mainly used, it's more complex to find the x value this way, but it's used if you can't factor straight from the original equation you have, and if you don't want to use a quadratic formula. And it's also used to get that vertex form that I was talking about, to actually graph these quadratic equations. So the last way to solve this quadratic, the last way to solve this equation, these quadratic equations, is basically to use the quadratic formula, which I'm going to talk about in the next slide. I'm just going to switch over to my PowerPoint real quickly. So basically with the quadratic formula, we have that standard form of ax squared plus bx plus c equals 0. So coming from that standard form and using those coefficients of a, b, and c, our quadratic formula comes out to be x equals negative b plus or minus the square root of b squared minus 4ac over 2a. So it's kind of a, you kind of, if you're going to use a quadratic formula, you have to like memorize it really. So it's a pretty simple formula to use because it's mainly just plugging in these coefficients. So I thought I would just do one example of this. And I think you guys should be good with that. So let me go ahead and switch back to, I will write out the quadratic formula on my notebook as we're doing this. And I'm going to switch to doing that notebook, writing out this equation. So the equation we want for this quadratic formula is going to be, so we're going to do the quadratic formula. So our equation is negative 5x squared plus 7x equals negative 9. So first things first, if we want to get it into this standard form of ax squared plus bx plus c equals 0, we want to bring the negative 9 to the left side. So we want the right side to be equal to 0. So negative 5x squared plus 7x plus 9 equals 0. And what I like to do, just because I don't really like working with the negative number for a, I like to multiply through this entire equation with negative 1. So when I multiply by negative 1, it comes out to be 5x squared minus 7x minus 9 equals 0. So here we can just identify our variable or our constants. So a equals 5, b equals negative 7, and c equals negative 9. And just to, I'm sorry that I had to switch back from the PowerPoint, but just to write out the quadratic formula, x is going to be equal to negative b plus or minus, because usually there are like two solutions, the square root of b squared minus 4 times a times c, and that's all over 2a. So let's go ahead and use these coefficients to get our solutions for x. So if we just plug this in, these coefficients, x equals, so negative of negative 7 plus or minus the square root of negative 7 squared minus 4 times 5 times negative 9. That's all over 2 times 5. So let's go ahead and try to simplify this. So negative times negative 7, that's going to be a positive 7, plus or minus, and negative 7 squared is going to be negative 7 times negative 7, which is 49. And we're going to go ahead and we can use a calculator or we can do this in our head. So 4 times 5, that's 20, times negative 9. So negative 4 times 5, negative 20 times negative 9. That's going to be plus 180 over 2 times 5, which is 10. Now we can just do one more simplification where we have 7 plus or minus square root of 229 over 10. And this again gives us two solutions of x equals 7 plus square root of 229 over 10 and x equals 7 minus square root of 229 over 10. So this is basically how to use these coefficients for the quadratic formula to get your solutions for x. And so that was our last way of finding the solutions to the quadratic formula. So that's basically the end of my PowerPoint for the quadratic equations. So basically we talked about what is a quadratic equation and how they look, how they're parabolas, and how they basically look when you have two solutions, one solution, or no solutions, no real solutions. And then we talked about the three ways of finding the solutions, which is basically solving for x or whatever unknown variable you use. And that would be factoring, completing the square, or using the quadratic formula, which will pretty much always give you a solution if you can't factor or complete the square. So thank you guys for listening. It was a pleasure.